Well, welcome everybody. Good morning, good afternoon and good evening. Welcome to BIM REC Webinar 16.0, Discover the Importance of Quality Data in the BIM Process. During today's webinar, you will learn how BIM evolved as a data-focused business process. You will discover why and how BIM creates more data than ever before. You're going to discover the exact steps required to create an environment where quality assurance is possible, what QA really is and is not. You're also going to learn how BIM can improve quality delivery across a wide range of disciplines and applications. The benefits of today's session, well, as we move increasingly into the world of BIM, the market is realizing the huge quantities of data that are being created. If that data is inaccurate, problems can and actually BIM will not be able to deliver its promise. David's presentation today is going to provide you with a clearer understanding of what QA means, why it is necessary, how it can be applied, and what are the benefits. Today's session should last between 50 to 60 minutes. It's going to be a bit different today. We're going to split it into 3 parts. It'll be a presentation followed by a live demo and then a Q&A session towards the end. I will be hosting along with David. As always, we do have a ton to get through, so we're going to move quickly and, as I say, take questions towards the end of the session. So please do make sure that you stay to the end. For everyone live on today's webinar, at the very end of the session, once we finish the Q&A and the session has finished completely, there'll be a pop-up box. A pop-up box which will appear, which will have a link for today's slides with David and a link for our next webinar as well with Professor Arto Kivanaimi on the 22nd of October. If you would like the recording of today's session, links for previous webinars, or to schedule a call with me via my online diary, please do not hesitate to type your details in the chat box to the right-hand side. If you require anything as well throughout today's session, again, put that in the right-hand side and I shall endeavour to get it across to you. Now, I'd like to say a quick thank you to everyone who has attended regular events. It's great to receive the positive comments from all you guys regarding the calibre of the speakers and the content of these sessions. With the BIM REC webinar series being an open invitation, however, we have a lot of new people attending today. So for those of you who don't know me, my name is Barry Hassib. I'm the Managing Director of BIM REC and AEC Recruitment. BIM REC are an essential recruitment partner for individuals and organisations really looking to win with BIM. We're devoted to helping our candidates, clients and the industry as a whole overcome any obstacles throughout your entire BIM journey, whether that's helping you personally or your team source world-class BIM talent or offering these online educational workshops with BIM leaders such as we have today. Now, for all the new people on today's session, we are often asked why BIM REC put together this series of free webinars. Well, whilst extensively surveying our candidates, clients and the marketplace as a whole, we discovered our industry still has a long way to go with regards to BIM, so what better way to help educate than bring BIM leaders directly to your desk. As you know, BIM is a journey. Some companies and individuals have had great success, whilst for others it's been a steep learning curve. My goal, whatever level you're currently at, is to really help you win with BIM, and helping ensure candidates, clients and the marketplace have access to world leaders who are experts in their fields. I'm very proud and privileged to announce we have Professor David Jellings with us today. David is the Managing Director of Solibri UK and a visiting Professor of Birmingham City University. David is presenting today on the importance of quality data in the BIM process. With that said, I would now like to pass you over to David and make David the presenter.
Hopefully you can see that.
Yeah, we can see that and we can hear you clearly.
That's fine. Well, good afternoon, everybody. This, to me, is a very, very important topic, and I'm delighted to say that it's not just myself who's saying this now. It's it's actually forming one of the areas of greatest concern of industry leaders and governments. People are beginning to realise that now we have an environment in which we can start to share and improve the situation as never before. We have to make sure that we're working with quality, and that's what I'm going to try and put across today, both with a short presentation and then perhaps more importantly showing what we mean in practical terms. I try to avoid wherever possible jargon. I'm a very simple soul, and one of the problems that I've seen in the several years I've been working in this market now is that there's a lot of misinformation in the market, and that comes largely from jargon. Experts talking at a level that they understand but not that the audience tends to understand. So I'll say right up front, if this in part is too simple, apologies. I'm not trying to patronise anybody, but hopefully what you see in the next 45 minutes or so will put more significance behind what the title is here. You'll have a better understanding. So where to start? Well, would you or any of you drive one of these had it been designed by the construction industry? Probably not, because we've grown up in an environment where we don't really have confidence in the process, and that's maybe okay in the case of certain buildings, but in the certain technologies such as high-speed cars, aircraft, rockets, etc., we simply wouldn't do it. Why? Some of the things that are coming up here are just comments that have been given to me over several years by people trying to describe the key failures of a traditional process in the construction industry. Hopefully you'll agree with some of these. Hopefully you don't experience it too often. But there is a fact that we don't as an industry have a basis that we trust each other and share information. Because basically, if we can't trust other project partners, as we're saying here, then we're generally unwilling to share data with them. And the result is incomplete or incorrect information, and that in turn obviously compromises quality. Most importantly, it destroys confidence. So why do we put up with this? Because we do, don't we? Well, there's usually somebody else to blame. Unfortunately, we do tend to live in a blame culture in this industry. But why? I don't know. My background is manufacturing, where the processes for the last 2 or 3 decades have been built largely upon trust and sharing. And in the construction industry, when I joined in 2005, the biggest difference that I saw was that this was an industry that was very often based upon mistrust. We keep information to ourselves. We don't like sharing. That's the traditional process. Something we have to overcome. So if we're going to have confidence that the design and build output that we have, we need to have a process which is based upon trust and collaboration. Because without that, we can't provide the environment that gives us quality information. And that's what we're trying to address today. Is that something that could describe BIM? Sure. BIM is an acronym that is actually confusing the market now, in my opinion. We call it, or we used to call it in manufacturing, integrated process. And that really is what we're working with in construction. We call it BIM. Then, of course, there's the other thing that we need to understand, and that is effectively how to communicate. Because if we're going to work in an environment where the whole basis of the process is trust and sharing, we have to find a way of communicating that. And that brings me to referencing a gentleman that I was fortunate enough to hear speak 20 or so years ago, a gentleman by the name of Dr. Joseph Bracich, who unfortunately has died some time ago. He's an Australian, and he was a psychologist, and he was expert in communication. And I learned something from him which has basically shaped my future from that time onwards. And that is not what is communication, but what is effective communication. And the he gave, and I'm going to copy now, is that of a father walking down the street with his young son. And as they do so, they come across a wall, and on the top of the wall they see broken glass. Now, of course, as any parent will know, to protect one's child, you have to get across the message that this is actually pretty dangerous, so you shouldn't mess with it. So let's look at how we can actually communicate that. Well, there's 3 ways we can communicate. There's the form that is instructive, so do not climb that wall. And if we take that approach, there's a 10% chance that when the father's back is turned, the boy will heed his words and not climb the wall. So the second way of doing it, we can say, well, let's explain. Do not do this because it will hurt you. Now, that's a little bit better, isn't it? Now we have a 50% chance of success in communicating, because now when the father's back's turned, at least the little boy has got something in his mind that may convince him not to climb the wall. But it still is not the definitive solution. The third way is to engage and to try the approach, what do you think will happen if you climb that wall? Then that starts the thinking process. Then the boy is likely to think, well, if I climb that wall, the chances are I'm going to hurt myself. So here's now reasoned why this shouldn't happen. And now there is a 90% chance of success. So it is proven in the world of psychology that communication by engagement is the best way to communicate. So that actually means that it creates a problem, because when we engage with somebody, we have to start to evaluate and understand far more data, because it's not now a simple instruction, it's now a consultative process, it's a process of sharing thought. So we have to start now to work out what this data means. And this requires a communication protocol. This requires a way that we can actually discuss, debate and share. And that's called a protocol. So in open communication, there are three ways in which we can develop this protocol, and I'm going to try and relate it to the construction industry in a very simple and unique way. Because if we are going to communicate across a number of people, then there are three ways in which we can do it, and they're called Bespoke, Single Platform, which in BIM terms is often referred to as closed BIM, and Common Platform, which again in BIM terms is often referred to as open BIM. That's about as technical as this gets. Let me move away from construction to try and explain what this means. I'm going to talk about the United Nations. Why? Well, the United Nations is an organization that has around about 190 sovereign members, each of which speak different languages. In fact, the UN, there are around about 50 separate languages which are spoken. So how does the UN communicate? Because here they have a massive problem. Because whatever it is that the United Nations is trying to achieve, it has to find a way to communicate clearly and concisely with its constituent parts in order to do what it is trying to do. So I'm not going to go for 192, I'm just going to choose 4 nations here, and they're chosen at random for no other reason than they speak different languages. So here we have China, Spain, France and Germany. Okay, so let's assume now that we're at the UN and we're trying to communicate information. How can we do this? Well, of course, one way of doing it is that everybody learns everybody else's language. Then we don't have a problem, do we? I don't know many people who speak 3 languages, let alone 4 languages, and 50 languages is just out with the reach of anyone. So, although it is a possible solution, it is a very difficult solution. And this is what we call a bespoke solution. Now, in technology terms, what this means is if those countries are represented by 4 different authoring tools, for example, then to exchange information, to communicate information between those different authoring tools, we have to determine and develop a bespoke communication link between each one. It can be done. It's expensive, it's not very efficient, and of course every time there's a new version of one of the authoring tools, the chances are that we have to develop a new bespoke communication link. So it is a solution, but not really a practical solution. So what else can we do? Well, there's another way we can approach this. I'm sorry if this is a bit scary because it looks as though someone's taking over the world. But here we have a situation where everybody, except one, has to change their language. So now we all speak Chinese. That would work, wouldn't it? Or would it? Are we actually in an environment, a global environment, where everybody is going to speak a common language? I think it was tried about 30 to 40 years ago in Europe with a language called Esperanto, and it failed miserably because people are not going to give up their sovereignty. Now, again, if we try to relate this to technology in the design authoring tool environment, again as an example, what we're basically saying is forget all of the BIM tools that are out there. And in the UK alone, there's almost 200 tools that have elements of BIM capability. Forget all of those, just buy one. Just buy one suite, and then you won't have a problem communicating, will you? Of course, that does restrict your choice somewhat. There are many software vendors that would like you to do this, of course, because that would enhance their sale. But again, in practical terms, it's not possible. But this is what is called a single platform or closed BIM. And this can only work if one technology provider can provide every element of the solution that is required within a BIM process. And to my knowledge, not one exists that can even come close to that. So it is a solution, but again, not a practical solution. So let's move to the third option. This is more appealing because now we have a situation where everyone can use their own language and we have a common interpreter. And in fact, this is the way that the United Nations works. So if I'm speaking in English to the UN, then my message goes up to a bank of translators who relay that back to the rest of the delegates, and the Chinese delegate, for example, will hear in his or her native language what I'm saying in my language. It's a system that works. And that is a system in technology terms which is called a common platform, or in the BIM world it's called Open BIM. So can this work? Because obviously this would make life a lot easier for most people. We do have actually a solution for this, and it's called IFC. You may have heard the phrase, you may have used IFC files. IFC actually stands for Industry Foundation Classes. It is a common communication protocol, and in technology terms what it means is if we have here those 4 separate authoring technologies from different technology providers, then they can work within their own protocol, their own language, their own design process, and then export in this common language which is called IFC, which means that anybody who can receive IFC can then import the IFC into their file and the communication is complete. Now, is it 100% effective at the moment? No, it isn't. It's probably 90% effective if it's used correctly, but it's improving all the time, and it is actually the only open common communication protocol which is available. And the other thing, of course, is there is no cost to the user. This is something that is developed by the authoring tools, so they have the capability to export and import IFC data. So it's not something that will affect the user in that sense. So okay, so we have so far identified that if we can have a process and we're going to base it on trust and collaboration, we have to have a means of open communication to share that information, and that will provide us in an environment that can create information and hopefully quality information. So what else do we need? Well, we now need technologies and processes to enable us to do that. So technologies and processes that can support the business process. The most important thing about BIM is, first and foremost, it is a working. It is a way of ensuring that all stakeholders in a project have access to the information that they require when they require it. That's a very simple definition of BIM, but it's as good as any I've heard. So BIM is a business process, so we need the technologies that can support that business process and communicate using open protocols so that the information that we can create can be understood and used by anybody irrespective of the technology they are using. This will enable us to have platforms now which can validate that the data is expected and present in the model, and above all, from my perspective, can assure that that data is correct. Now that's what I want to focus on for the next 5 minutes. These technologies and processes that can give us this environment that can provide the quality that we seek. So why do we need to do this? Well, if you weren't aware of it already, in this BIM world the industry is changing, and it's changing quite dramatically. To date, most of the work and effort has been put into this area, creating data. In the BIM world, this is what comes primarily from the authoring tools, but not exclusively. It can come from any form. But if we just again look at the authoring tools, what we're looking at here is the architectural, the structural, the landscaping, the electrical, the mechanical, that multiplicity of tools which create data. And there are a lot of them, and they are all pretty good. We're very, very good at creating this data. However, creating data is simply a cost to the business process. you don't get any payback for just creating data. You only get the cost associated with providing the technology that can give you that data. The payback comes when we can exploit or apply the data that we've created. So what we have to do effectively is to find a link from this, which we can do very well, into this area, and unfortunately this is the way that a lot of technology has tried to approach it. Now, this is not to knock in any way, shape or form data creators or the common data environments that allow us to share. It is quite simple that those technologies are not designed in a way to communicate in the way that we need in this BIM world. So when we've got this modify, fudge, link and add on, this is not in any way knocking data out there, knocking software vendors out there. It is in fact a reality. So we have to find a way to make this link. And what do we need to do? Again, in very, very simple terms, I tend to look at a project as a completed picture. And so if we have a completed picture and that's the project, then to create that picture, it's a bit like a jigsaw puzzle, isn't it? We've got to find a way of creating that picture from lots and lots of different sets of data. Now, as we all know, the best way to create a jigsaw puzzle is to start with a picture and to stamp out the pieces. That way we know they will fit. In a construction project, that is not possible. We can't start at the end. We have to start by creating the data in individual data sets that can actually fit together to produce the picture which will be the complete project. So that's the data creation, and here's the data exploitation. So how do we get from point A to point B? There's lots of processes involved in this, but essentially the two that are critically important are called federation and quality assurance. Federation is the process of bringing together data from different sources. It could be from different authoring tools, architectural, structural, MEP. It could be from a number of sources. But it's a way that we can physically bring these things together so that we can see them working in unison. That's the process of federation. That's the first thing. So the pieces fit. The second thing is to ensure that the information that is in each individual data set or data piece of the jigsaw can be understood, is correct. Does it mean anything to the other pieces? Can we actually transfer the data correctly? So the second element we need to ensure is that the way that we create data is in such a way that we have the quality information that we require to complete the picture. So now if we go back to this original diagram, in the UK we've been quite fortunate in that we have had a government lead which has been quite revolutionary in its foresight. And whether or not we like what the government has done or how the government has done it, it has given us a lead. It has given us some guidelines. So for the Federation and Quality Assurance, we have things like the PAS 1192 suite, which looks at the BIM process and the elements of the BIM process that make up the requirements to communicate data correctly. We have classification systems, and all a classification system in simple terms is a naming convention so that we can ensure that the components which make up the data within the individual data sets is in a common form so it can be understood by other data sets as well. And Uniclass is an example of that. We have a communication protocol, IFC. So we have a way and a means of doing this. So we have a process to give us a guideline of how to do it. We have classification systems, so the information that we're transferring is in a common form, and we have a common communication protocol to enable us to actually transfer this information. That's where my company Solibri actually sits. We work in that area. So if we look at what we mean in more practical terms, these are just some examples of the authoring tools that I've been talking about. There are many of them. So this is the data creation. This is the data utilization, and again, it's just some basic examples of what we mean by utilization. How can we use that data correctly? And what we've looked at is a way of transferring the data from the authoring tool into the utilizing tool in a way that can be understood and meaningful. If we can take this sort of approach, then we've taken the first but massive steps towards an environment which will give us the ability to not just create data, but to share accurate data. So the last thing before I come on to a practical demonstration is just to ensure that we avoid one area which is beginning to confuse the market, and that is the difference between validation and checking, because a lot of the documentation that's being produced now refers to both. So what do we mean by this? Because there is a big difference. But they are both the essential elements of quality assurance, because validation is a process which ensures that data is present, and indeed can validate the source of that data. So if we are expecting data to be present, validation can tell us, yes, the data is here. This is where the data has come from, and the data has arrived on time, or is late, or is early. That isn't particularly difficult to do. The second area is checking, and that's a process which ensures that the data that we have is correct, and that's a slightly more complex problem to address. Let me just give a couple of examples of what I mean by this, and for those of you who've come across COBie, then COBie validation is provided by a number of means, most of them free, which is good. But validation is saying the data, does it exist? Is it there? So here we have just an extract from a COBie spreadsheet, which some of you may recognize. If you don't, then all a COBie is an asset register which is represented through the form of an Excel spreadsheet. There's a lot more to it than that, but visually that's what you're seeing here. So validation is asking two things. Is there data present in the required field? So have we got something there or not? And the second question, is the data in the required field on time, or is it late, or is it early? Now this is immensely useful because it's telling us that we do have information that we can work with, or we don't have information that we can work with. But the critical thing is the validation process does not tell us if it's the correct data. So checking is the data correct requires something a little bit more. And here we've got a picture which is basically saying that we have a problem here because some of the elements in this particular model do not have a name. And in COBie terms, that means if it doesn't have a name or it's not classified correctly, it can't be extracted, so it can't exist in the COBie spreadsheet. So that's the difference between the two, and I'll be showing this in a little bit of detail very shortly. So in summary, if we say that BIM is a process that's based on collaboration and trust, which of course it has to be, which provides an environment which enables us now to create and share project data via a computer model, which is what a building information model is. It's a virtual model. Then compared to traditional methods, we can now create far more data than we've ever created before. However, one warning, and this is a serious problem that the industry is beginning to understand as they start to work with more and more data. If the data is not correct, then we're potentially creating more problems than we're solving. And quite simply, BIM cannot deliver on its promise. So the importance of quality assurance in a data where we're creating more data than we've ever done before becomes absolutely paramount, because it says there, if we're not doing quality assurance, then quite simply we are potentially creating more problems than we're solving. Okay, so I've spoken a lot over PowerPoint, and hopefully that sort of set the scene. But what I want to do now is to have a more practical demonstration. Now for this, I'm using Solibri software. Some of you may know it, some of you may not. This is not an exercise to sell Solibri software, but this is an exercise to show and reinforce some of the points that I've been making. Now, despite the fact I work for the business, I'm not a technologist. I'm not very good at operating software, so if I push the wrong button, I'll apologise in advance. But I'm here to show you what the software does. I'm here to show you what this BIM process can do. I'm here to show you what the IFC process does. So here we've got a model. It's not very exciting, except that this is a building information model. And it's a building information model that is made up from a structural, an architectural, and an MEP pack. And each of these are from different authoring tools. But the common factor is that the export of each of these designs has been in an IFC format. So what we're doing, we're collecting from 3 different design sources IFC files which can be brought together. So this is a federated model. You can't easily see the distinction between the structural and the architectural, but you can just about see in there the MEP components. So we have a model, and we can walk through it, we can cut it, we can paste it, we can spin it, we can do sorts of things that gaming technology does, but I'm not here to talk about that. The important thing here is that this is a building information model. So as well as being able to see and walk through it, I can click on any component, and down here I can extract its IFC properties. So if you're not familiar with IFC, this is what IFC can give you. So we can give you, first of all, the identification. What is the model? What is the architect? What is the source? What is the component that we're looking at? Its type, its materials, its layers. It can give you the location, the precise location in there. It can give you the quantities. It can give you details of the material. It can give you a profile of those materials. It can give you, very importantly, the relationship of what that material is or what that component is. So, for example, if it's an air extract, then the requirement of an air extract duct in a secure area or a high contamination area is very different from a public area. So the relationship of where the components are within the building is important. It can give you classification systems. So all of this information is inherent in every component in the building information model. Okay, so now we have a federated model that contains a lot of stuff, a lot of data. So how can we use this to quality assure? Well, what I'm going to do here is to do a couple of very simple exercises, because with this particular software there is the ability to create what are called rule sets. Now, a rule set is very, very simply a collection of questions which have been converted into algorithms. If that sounds technical, what it means is we've taken a question and we've put it into a technical format that can interrogate a model. And the questions could be very simple. It could be, I want to know the distance between point A and point B. Or I want to know where components touch. I want to know what happens if that component moves from point A to point B. For example, if I open a door, does it encroach on the public? Does it encroach on another wall? Does it encroach on a column? So these are simple questions, and we can create these questions and put them together in such ways that we can start to now ask quality questions of the model. So I have up here 2 rule sets, and these are collections of questions. The first one is called a validation rule set, and in here we're asking the sort of questions which are logical in terms of construction. So, do components touch? What happens if? Is that component in the right place relative to that component? All of the questions that you can think that are collectively asking the basic question, is this something we can build? So that's one set of rules I'm going to apply here. The second set of rules is what is commonly known as a collision rule set, and here what I'm asking for is any instances of clash or collision between the MEP model and the architectural model. So I've got the questions up here, I've got the model down here. To actually apply in this software, we simply push a button that says check. As you can see, the green bar going across. What we're doing now is trying to establish if this thing has found any problems. And it has. We've graded them subjectively into red, which are severe, amber, which are important, and yellow, which are things that you may want to look at. Rather than explain that in detail, let me give you a couple of examples. So what I'm going to do here is just to expand this rule set the same as I would expand any file system until I get down to root. And if I move this across, you'll be able to see this in full detail, but you'll lose some. My screen's a bit squashed here. So we've got something here which says components above columns. What does that mean? Well, if I click on it and this box opens, if I click on that, it shows immediately what the problem is that it's located. And hopefully you can see that very clearly and very visibly. The columns here don't reach that slab. Now, it may be possible that there's a reason for that. I can't think of one, but it may be possible that this slab is suspended on hooks. all the software is doing is saying from the model, using the process, using the protocols, we've identified a potential problem, which you, the experienced operator, can now say, yes, it is a problem, or no, it isn't. And if I say, yes, it is, then I can create a slide which records the problem. I can describe it. I can put some comments in. I'm just putting gobbledygook here for speed, and I've created a problem. Let me take another one. So now we've gone to the MEP model and the architectural model collision rule set, exactly the same. By expanding this, I've now reached a situation where, again, you can see instances where components are clashing. And again, I'll just now create that as a particular problem slide and put some comments on. And so the quality assure in the BIM world now becomes quite easy, because we've got the questions to ask, we have the model, and we simply run through them and identify every particular problem that's being located and say, is it or isn't it a problem? Having done that, we need now to communicate that back. So from the results I just checked, these are the two problems I found. I can send those through now back to the source so that the source designers can make their particular changes. So we've identified some problems and we've sent them back to source. This is not new workflow. This is the way that these systems currently work. It's just that it's done manually. And in the BIM world, we can do this now automatically with the additional data and the technologies that we have. So having done that and having sent that information back, the next stage is to make sure it's been done. So I'm now skipping to the next phase of the process. And now we're assuming that all the problems we've identified have been corrected. And so now we can have a situation where the original model, which is called the old model here, is now compared to the new or the corrected model. And in this case, the rule set is basically saying, show me every instance where the components in the spaces have either been added to, removed, or modified. So I'm doing, it's like a 3D light table. I'm superimposing two 3D models. So what have we found here, or what can we validate? Well, if I go to the first line here, which is the column geometry, then I can see fairly quickly and easily that those columns that we identified were short have been extended. And of course I've got all the properties down here. So we've got a very quick and easy way of checking that the work we've required or requested has been done. That's the process. It really is simple. If we have the right communication technology and the right process to put together the models, then it doesn't matter how much data we have. In fact, we welcome the data, but we can now validate and check that that data is correct. How far can we actually go with this? I've just given some very simple examples. Here we've got a situation where we're applying some building regulations. In this case, it's US building regulations, accessibility and egress. I think in the UK we call them Part M and Part B. So we've applied the, or we've coded the building regulations, and we've applied those coded rule sets now to a model. And these are some of the things that we found. So in terms of accessibility, the first one we've identified is that when these doors are opened, you can probably see it visually, the distance between them, it says down here specifically, is 472 mil. It should be 1.22 mil. In other words, that gap is too small. It's a breach of regulation. Now you could easily say, well, that's just bad design. Anybody should be able to identify and correct that before it gets to an advanced stage. Perhaps you're right. Here it's identified a situation where the slope of that ramp for a wheelchair is 1 degree out. Here we've identified that the risers on those stairs are 203 millimeters when they should be 178 millimeters maximum. So we've got potential rework on site. Goodness knows how much the cost of that would be. What is the level of detail that we can go down to? Well, here we've got a situation where the turning circle of a wheelchair in that toilet compartment actually clashes with a sink. So we can use this data-rich environment, if we can control it, to identify potential problems with the design before they move forward into the design environment. We also have the ability to interrogate these in a very advanced way, and the last part of this demonstration we'll look at an area called COBie, which I've touched on before. Here we have the model that we've seen, but this time we're checking it for COBie compliance. So we're asking the sort of questions in here. Does the model contain the information that is required to complete an asset register, or in this case a COBie spreadsheet? So we have rules set specifically for that. So the basic rules are looking at do we have, and in this case I'll take a CIC stage 3, do we have an environment where there's a problem? Let's look at what that problem is. These components do not have a unique identifier. So these are the components in that model that are not identified. Those are the components that cannot be extracted automatically and put into the asset register. So we can have rule sets that look at pretty much any area of quality requirement. Okay, I don't want to go much further now because I think it's time to try and digest this and get some questions and hopefully try and answer those for you. But basically, what I've tried to show in the presentation and this demonstration is that, firstly, we have to admit the traditional processes that we're working with are flawed. If we don't admit that, then we may as well stick with the drawing board and not move into this BIM world. Most people have realized that we have actually got the BIM world, and the BIM world is now a situation which enables us to create data-rich environments. That in itself can create a problem, because if we're creating lots of data and we can't utilize that data in the right way, then we're potentially creating more problems, or even worse, we're creating data that we're not going to use, so we're just throwing money down the drain. But if we are going to use this data, we have to find a way to bring it together in such a way that it is useful. If we can do that, then I've shown one of the areas that we can start to now utilize this data, and this particular area that I focused on is the area of quality assurance, and it's only just scratched the surface, but hopefully that has got some of the message across. So Barry, I'll go back to you now, and let's take some questions if we have some.
Fantastic. Thank you, David. Superb presentation and demonstration as well. It's been really good seeing the demo. It's something that we don't normally have on these webinars, so thank you for that. Yeah, we do have quite a few questions. I'd like to open up questions as well. Again, to questions to the right-hand side on the chat box. Just chuck any questions in there that you do have. Are you fine to just jump straight into it, David?
I'll do my best, buddy.
What's the importance of quality data, and how do we best get this quality data?
Well, I'm glad somebody's asked that question to start off with, because hopefully that's what we've tried to address through the presentation. So I assume this was a fairly early question.
Sure.
But the importance of quality data, I come back really to the main message. In this data-rich world, we're creating more data than ever before. If that data is incorrect, we cannot deliver on the BIM promise. It really is as simple as that. And the way that we get this quality data is by creating the models, creating the BIM environment in such a way that we can interrogate it intelligently.
Sure, fantastic, thank you. I suppose this is a very relevant question. How reliable is Solibri when it's compared to, say, Navisworks?
Well, okay. I think the first thing I'd say there is Navisworks a competitor to Solibri? And the answer is no. Navisworks overlaps slightly, and Navisworks does collision detection, for example, which Solibri does. But that's about the only area that we overlap.
Sure. And
at Solibri, we think that collision detection is maybe 5% or less of the entire quality checks.
Okay.
Navisworks is a very good tool in other areas, so it's a very good visualization tool. It's a good way of doing 4D timelining, for example. Yeah. And most of our customers are Navisworks users as well. So the answer quite simply is Navisworks reliable? Yes, it is. Is Solibri reliable? Yes, it is. How do they compare? You're not comparing eggs with eggs. Sure. They're complementary rather than overlapping.
Sure. Okay, fantastic. Thank you. Most cost-effective way to store data and have it reside with the project instead of the professionals? Apologies, I need to clean my glasses.
Yeah, that's a damn good question. Yeah, the traditional way of storing, as we know, has been that the professionals, by that I assume the person asking the question means the design professionals and the project professionals that create data and then tend to keep that data to themselves because that's the way it works in the process.
Yeah.
And the only visible data that the client, the person who's paying for all of this, sees at the end of it is the asset register. So they get a pile of documents with all this data in. Now, of course, now we're working in a data-rich environment in a digital world. There's different options, and the preferred option, which is now rapidly being adopted across the cycle, is to use one of the many common data environments that are out there. So basically, if we're creating information digitally, we can store it digitally, and that means that we can access it digitally. So everybody who needs the information can get access to it.
Yeah.
So I would recommend that on projects, if you've not looked at common data environments, you do that. The protocol of setting that up obviously is down to project specific, but that is the way I would do it every time.
Sure, okay, fantastic, thank you. What is the sensible level of detail and data, so not to exclusively load the BIM model, making the file size too large? Recently, larger projects have had to be cut into separate models as the file size is too large.
Yeah, this is this comes up quite often, Barry, and I think again it relates to the actual process we're using in creating this.
Right.
So one of the problems that we've got is if we've got an authoring tool which can give us all the whistles and bells, and we can model down to screws in doors and hinges on doors,
yeah,
there's a temptation to do that. Now the problem is when we do that, of course, we're creating a huge model in terms of data size, and you know we're creating models not in megabytes but in hundreds of megabytes or gigabytes.
Sure.
And that makes manipulation of the data that much more difficult.
Yeah.
Now I'm not saying that there's not a need to be able to model to that level of detail. There is.
Yeah.
But in the BIM world, generally speaking, what we're looking to do, if we're modeling to that level of detail, it's because a specific discipline needs that.
Sure.
When we're looking to federate or bring together, then the structural engineer, for example, doesn't need to know how many screws there are in a door.
Sure.
Or the makeup of a wall. He just needs to know the basic geometry. The same as the architect doesn't need to know all the engineering calculations and the rebar in a structure.
Yeah.
So the crucial thing here is that when we're sharing information, is that we share the information that is required and not just do a download and dump of all the information.
Yeah, sure.
Now, we can do that because with IFC there are different layers of information that we can send. So if the architect wants to send information to the structural engineer, he can send just the geometric data, for example, and strip out all of these layers, which means that we're not working with massive files. The other beauty of IFC is that when we use IFC to federate models, because of the way the schema works, the data actually can be compressed quite dramatically. So in Solibri, for example, if we take an IFC file from something such as Revit or ArchiCAD or Tekla, then we can compress it in an IFC file and reduce the file size by a factor around about between 10 and 20.
Well, okay.
So there's lots of ways of getting it, but it's not a technology problem, this, Barry. This is more in terms of the process of how we're modelling.
Sure.
And if anybody has this problem, if they speak to their the guys at their authoring tools, they'll be able to help them reduce the size of the models and export and strip layers out with IFC.
Superb.
Very good question.
Superb hint there as well, thank you. So then who should take the lead of defining the data requirements for a project? Architects, owner, builder, government agency, or other?
Well, yeah, okay. You know, as a consultant, I should charge for the answer for this one, and most consultants. But again, I'm going to try and keep this very simple because, firstly, there is no correct answer to the question.
Sure.
Because it depends largely at what point of the project we are at. Because in the design phase, for example, the lead designer is the obvious one to take charge. When it goes into construction, the contractor is the one to take charge.
Yeah. At
the early stages, it may be the project management, or at any point. I like to think of it in terms of, have you seen the pursuit cycling, when you get about 4 or 5 riders going around the track with about 2 inches between their wheels?
Yeah.
At amazing speed. And what happens at the end of every lap, the one at the front pans out and the other's far forward and he latches onto the back.
Sure.
So they're constantly changing the lead.
Yeah.
And I think in a BIM process, that's what needs to happen. The person or the discipline which is working at that particular point in the project, which has the most need for the data, is the one that should take the lead. Why should we lump it all on one person?
Sure.
Because BIM is about sharing.
Yeah.
And so the most appropriate person is the one that should do it. That's to say there's not a definitive answer, and hopefully that made sense.
Fantastic, and good analogy as well. Thank you. Okay. Will BIM across the broad range of CAD programs ever reach status of a level playing field?
Cool. I'll tell you, if you ask 10 CAD vendors, you'll get 10 different answers to that. Well, I can speak from a neutral point of view because I work with buildingSMART, and the software I work with is totally CAD neutral, so it doesn't really matter.
Sure.
Will it ever be across the board? I think it'll get very close, because now we've got, now we've got the protocols and things like IFC. It means that the world is shrinking slightly in that sense. The problems are shrinking, and it's really been enforced by the fact that now the big projects themselves, and I can't name them, but the big projects I'm working on in the UK, billions of pounds worth of projects, are now generally specifying native tools as well as IFC files.
Right.
The next stage will be we just want IFC files. Now, the minute you've got that, then everybody is on a level playing field, because now users, and this is so important, users can, if we have this common communication protocol, they can select the technology which best suits their particular needs, rather than a technology that they have to select because it communicates with the project manager. And that is what Open BIM is all about, and this is why this open communication platform is there. If you think of every other industry, Barry, this is what has happened. And let me give you another analogy. I don't know if you had a mobile phone in 1990. Can you remember 25 years ago?
Bricks.
Yeah. Yeah, I did. It was a brick.
Yeah.
And there's 2 things I remember about it. I had muscles like a gorilla because it was so heavy, and the batteries used to last about 2 minutes.
Sure.
But the main thing was, if I wanted to communicate with somebody, then providing they're on the same network as me, and the conversation was less than 2 minutes before the battery packed up, it would work.
Yeah.
If I wanted to speak to somebody on a different network, forget it.
Yeah.
If I could do it, then the cost was 10 times as much, but it probably wouldn't work anyway. Now, that changed in the mid-90s, and I can't remember the exact details, but I think it was one of the few times that the United States Fed and the European Union colluded successfully, and what they basically said was to the network owners, we've had enough of this. You have to now have a network which has got a common communication protocol. So Mr. Vodafone, Mr. O2, Mr. whoever you are, and if you don't do that, we won't give you a license.
Yeah, brilliant.
And you know, it was remarkable. Within 6 months, everybody had a common communication protocol, which meant that now I could speak to anybody, which meant that the usefulness of the phone became so much greater, which meant that billions of dollars were poured into the development of mobile phones, which means that a mobile phone now is a portable computer.
Yeah.
And it's the most common communication. Now, that would not have happened unless we had a communication protocol. And so, yes, that is what is going to happen to the CAD programs in the future. And I'm sorry to any software vendors out there, a big shock for you guys. In 10 years' time, your software will be free.
Yeah. So that's the route it goes on. History repeats itself, as they say.
Yeah, that's how my background is manufacturing, and that's what happened. Most of the things are free. It's the data manipulation you're paying for, not the software.
No.
So software vendors beware.
Fantastic, thank you. How do we best make the information in a model available for space and FM? Okay, it's getting a little bit technical now for me, this.
So, but available for space and facility managers, how do we best make the information? Okay, let me try and answer that question from the point of view of the facility manager. I'm the one who's paying for all of this at the end of the day, or I'll be made to pay if the building doesn't perform, and
Sure.
and it's a critically important role because, as we know, 90%, certainly 80% of the whole of life cost of a building is after handover. So we've got to get the facility management right. So how do we make best information, the information model best available for this? The government's trying to do it by adopting COBie,
yeah.
so that we're taking information from the model and putting it into a common data form, which we've still got the work to do, or industry's still got the work to do, to be able to take that in a useful format and integrate it with the facility management.
Yeah.
All I will say is that from a technology point of view, if the data is there, which it is in the model,
yeah.
then providing it's being correctly defined, which is the process, then it should be a logistical exercise of software development to now suck that data out and put it into the facility manager software in a form. I know there's work being done on that. It's not quite the missing link, but there is work that's required. But there is no reason technically why this cannot be done.
Sure.
And I don't think we have to make any modifications, major modifications, in terms of the information in the model itself. So it's a roundabout way of saying it isn't a problem,
yeah.
but it's important that we resolve it, and the data is there. It's data manipulation.
Sure. Okay, fantastic. Thank you. This question's come in a few times, actually. Does COBie work for building services?
Oh, yes. Yeah, I mean, if you think of what COBie is, an asset data store,
yeah.
Then when you are operating a building, the most important elements generally tend to be the services, the building services in there, the heating, the ventilating, the air conditioning, the security systems. Those are the ones that require the ongoing maintenance.
Sure.
Yeah, you might need to replace your windows every 20 years, but you might need to replace your light bulbs every 6 months or something like that. So COBie really is geared up towards the building services more than anything else.
Brilliant.
What we have to bear in mind is that COBie is still in its infancy,
sure.
and there are teething problems and misunderstandings of what we're trying to achieve. So bear with it, guys. I mean, COBie works. It may be a pain in the backside, but it's a pain in the backside because it's a different way of doing what we've always done.
Everything new always is a pain in the backside to start with.
Absolutely, yeah. Once we get over it, in 5 years' time, we'll have cracked all this and we'll be saying what was all the fuss about.
Sure, yeah.
But we've got to go through those growing pains. So COBie, building services, ham and eggs.
And chips.
Yeah, and chips.
Okay. How do you ensure data integrity?
Right, well that's almost come full circle back to, I think, one of the, if not the first question, one of the early questions, which is, again, reinforcing, if we want to validate the integrity of the data, then we have to find a way of, first of all, creating the data in a way that we can interrogate, and that's the building information modeling process.
Sure. We
then have to have the technologies that can create the data physically within those processes, and then we have to have the technologies which can interrogate the data. If we've got those three elements, so create it properly in the first place, make it available and communicate it properly, and interrogate it properly, then effectively what we're doing is data integrity checking.
Sure.
What we're talking about here is not new. It's only new to the construction industry.
Yeah.
In 1969, we put a man on the moon. Do you think we did that without quality assuring and data integrity of the Apollo rocket? You know, we could do it then. You know, the sort of things we're talking about here today are what the manufacturing industry have been doing for 30 years or more.
Sure.
If you develop and design an Airbus, it may need a few test flights to tweak out the problems, but you know it's going to fly when you take off.
Yeah, sure.
So, you know, let's not overcomplicate this. Every other industry has done this. They've cracked it. They've resolved it, and it's just a normal way of working.
Yeah.
It's only the construction industry because we think we're different. and we're not.
Yeah, no.
So welcome to the 21st century.
Yeah, no, fantastic. Are you okay for a few more questions, David? There's a ton.
Yes.
I appreciate the hour's gone now.
Yeah, I'm okay as long as people have still got time to hang on.
Fantastic. What I would have, David, quite a few people have asked for your contact details. Do you have a slide that you could put on screen there so people can have your contact details?
Yeah, what I can do is if I go back to this, brilliant. There we are. Thank you everybody for supporting. And what I'll do, I will
have your email or telephone number.
I'll say I'm a bit of a, not a technophobe, but if I put in here,
so david.jellings@solibri.com. Yes.
Yeah.
Fantastic.
That's it. So I'll leave that up there.
Fantastic.
I'll put it in a better colour. So. Oh no, it doesn't want me to put it in a better colour.
That's not a better colour.
Yeah, hopefully you can see it.
Yeah, no, yeah. Fantastic. So david.jellings@solibri.com. Yeah,
I'll leave that up.
Fantastic.
Not in capitals, by the way. It's just I've got caps lock on. I told you I'm a bit of a technophobe when it comes to machinery, buddy. I'm not very good at it.
That's like myself. Okay, a couple of questions. Does Solibri also work with infrastructure BIM projects?
That's a wonderful question, and I wish I could give a positive answer. Yes, we do, but it's only on a limited basis, and the reason is nothing to do with the Solibri software. It is to do with the IFC development with infrastructure. Now, two things. First of all, Solibri, we made the decision to work exclusively with IFC.
Right.
We can do other file formats, but we're exclusively IFC because we don't think there's any point in doing anything else.
Sure.
Now, infrastructure is developing its IFC capability, so we can do limited things, but we're restricted by the IFC capability of the authoring tools in infrastructure, not by the technology. So I wish we had it, but realistically, I don't want to give any misleading answer. We are working with some of the biggest infrastructure projects in the UK at the present moment in time, and indeed globally. But realistically, we're probably 2 years away from when I can say, yes, Solibri can now do infrastructure.
Okay, fantastic. So not yet, but coming.
Yeah, watch this space.
Fantastic. Another question. She said, Cheryl said, thank you. Hi, thanks for the demo. I have a question. How do you modify a rule set?
Yeah, okay. Again,
not being a technical person.
It's a technical person. All I can say is this. I've been on the training course and I can do it, although I wouldn't dare dream to try and do it live. But if you think of a rule set as a simple question, so right back to when I was doing the quality assurance on building regs, those doors.
Yeah.
If you remember, let's see if I can just bring up the particular example, make it a bit easier. So that was the one, I think. So here we've got a situation where it's identified the door. Now, the rule that's been written, and you can see what the rule is down here, because the rule is actually, push too many buttons. The rule is actually saying, according to the guidelines, the doorways and doors in series, that's what we're breaching, that the minimum distance is 1.22 meters. So this rule has been written saying between point A and point B, in this case doors, there has to be a minimum of 1.22 meters. So anything that is less than that comes up with an alarm.
Sure.
Now, you can get into that rule set, and let's say in the UK it's not 1.22 meters, it's 1 meter.
Yeah.
And all you have to do is to get into the rule and change 1.22 to 1. So it isn't difficult. What you do need to understand is that you do need a bit of training to understand how to actually access the rules. But once you've got into them, it really is just simply changing a parameter. And anybody who's used to working with authoring software, this is a piece of cake. It's not how you manipulate it, it's how you understand the problem in the first place.
Sure.
So, you've got to be construction savvy to know what you're doing with the questions.
Okay.
But very, very easy to modify, but I ain't going to show you, sorry. My technical director would extract certain parts of my anatomy if I tried that right.
Okay. A question's coming from Alex, actually, talking about building regs. What were the building regs used during this demo?
Sorry, could you repeat that, Barry?
What were the building regulations you were using during this demonstration?
Right. In this particular case, these are, I think I'll expand it. The American Disabilities Act, the American with Disabilities Act and the American with Something Act accessibility guidelines. So that's our Part M. Now the reason we've got them for the States is that there's been a big project over there and we've developed the rule sets. In the UK it's not as clear because there's lots of different interpretations, but the basic rules are the same. So we can modify the existing rules. In fact, we're working with a couple of notable names in the industry, and I won't give those names because we're under non-disclosure with them, to develop those rule sets.
Yep.
The second one is egress analysis, and if I give you an example of an egress, this one's as good as any, where this is fire regulation. So from that room, it's saying here the access to the nearest fire door, which is there, is 107.04 metres approximately, where it should be 30 metres. So that's fire regs, which I think is Part B in the UK. I'm not an architect, but I know one of these is Part M and Part B.
Sure.
In theory, you can do any. If you can think of the question you want to ask, you can write a rule for it.
Brilliant. Okay. So another question. So you can integrate. So with Solibri, you can integrate models from numerous modelling programs and make it one model.
Yes.
Yeah. Brilliant. Okay. Yeah. I thought that's what you were just saying. Are the rules predefined, or are they imported from some other source, and how much programming is needed to set up the rule?
Right. 95% or probably higher of the rules are generic and provided with the software, so you don't have to go out and buy rules. And that will cover pretty much every activity that you've got.
Yeah.
So things like collision and logical rules of construction, they're generic anyway. It's the same irrespective of where you are. The only things that will change are things like building regs, because they'll be different from country to country.
Sure.
Or COBie definitions will be different from country to country.
Sure.
But the way I would answer the question is that in Solibri we have rule templates, and there's about 60 of those, and a template is one that asks a question. So
right.
The template might be distance from point A to point B.
Yeah.
Now, if you think about it, there are an infinite number of variations on that template.
Sure.
So the generic rules have covered all of these, and they provide it. Now, the only time you would need to modify is if you're working with a particular client or on a particular project where you may have something that's very specific. For example, one client I'm working with at the moment, now named Patrol, has a minimum requirement that the room's height in their particular building has to be 2.5 metres.
Yeah.
Otherwise it doesn't meet their spec. So it's very easy to develop a rule to check the model to say do all the rooms have a minimum height of 2.5 metres.
Sure.
Because the rule itself is there, it's just changing the parameter. So 95% of everything you'll need to do with Solibri comes out of the box.
Brilliant.
The other 5% is the tweaking, the richness that you can get from modifying your own rules.
Sure, fantastic, thank you. One more question. So I am conscious that it is over the hour mark now. Do you believe BIM is for the next generation, or do you believe the current generation to adopt? We, us young folk, find it. Thanks, Alex. Find it difficult convincing the more experienced folk that there is a more efficient way of doing their job.
Well, let me just say, Barry, I'm 60 years old this year.
Sure.
So you can teach an old dog new tricks.
Yeah.
That's the first thing. I know exactly where the question is coming from.
Yeah,
BIM is here. It's here to stay, and it will be for a number of reasons. First of all, it's the most common sense way of doing things. Secondly, every other industry, bar none, uses integrated process. And thirdly, if we don't do it in the UK, it's already been done in Scandinavia and the Far East.
Sure.
We're not going to have a construction industry.
Sure.
So we've got to do this. Is it here to stay? Somebody once said to me, when we can't think of another way of doing it, or when it becomes the norm and we can't understand why we did it any other way,
yeah,
then it will have hit. Within 5 years' time, I think we'll be saying that question.
Yeah.
So what I will say to the questioner, because they're obviously a damn sight younger than I am, if you can acquire the skills and understand BIM properly, and I'm not just talking about how to model, but what BIM really is,
sure,
if you can master that, your future is guaranteed.
Yeah. Yeah, there's some real bright
and the
students
best
as
of the
well.
team.
Real bright
Yeah.
students coming through at the moment, which is fantastic. Well, on that note, I'd like to say thank you, David. Thank you, everybody, for attending today. You do have loads and loads of thank yous coming in on the chat box. There's quite a few questions as well.
Nice.
For Tracy, thank you for all your questions. Apologies we haven't got time to answer all of them today. Tracy's an avid fan of Solibri from the sounds of things, David. So Tracy, by all means, please do email David directly at david.jellings@solibri.com. Yeah, a load more thank yous coming in as well. Yeah, so thank you everybody for attending. Is there anything else that you would like to add at all?
From my end, no, it's been a pleasure, and all I'll say is I've got lots of questions coming in. Give me a little bit of time to answer them. I have a day job to do as well, but it's been a pleasure.
As well.
The most important thing to me is not just the software I'm in. A third of my time is spent working with universities, government, and buildingSMART.
Yeah.
It's getting the message across.
Sure.
And if I've done that today, that's more important than talking about the software that I run.
That's brilliant. Thank you, David. Well, there's quite a few people as well that have downloaded the COBie Trial, so that's good news there as well. Yeah, no, fantastic, definitely. What I will say as well, everybody that has held on, thank you. Thanks for attending today. I know you must have taken away some great content. As mentioned earlier, our next webinar is with Professor Arto Kivanimi. It's on the 22nd of October. A link to that will be provided once we do close down here. If anybody wants to get in contact with me at all or to schedule a call in my diary, please don't hesitate to go to bimrec.com. With that said, thank you once again, David, and thank you everybody for attending. I look forward to
My pleasure.
Seeing you all at a later stage. Thanks again, David.
Okay, thank you, buddy, and I'll say goodbye now.
Yeah, you take care. Thanks now.
Cheers. Bye-bye, folks.
Bye-bye.